What if I told you that right now, someone could be sitting between you and your favorite website, silently reading every message you send, capturing every password you type, and even modifying the content you see, all without you having any idea it's happening? Welcome back to TechSky's Ethical Hacking Masterclass. Today we're diving deep into one of the most powerful techniques in a hacker's arsenal, man-in-the-middle attacks, or MITM for short. This isn't just another basic tutorial. Today's video is a comprehensive masterclass on MITM attacks. We're going to take you on a journey through the entire landscape of these sophisticated attacks. We'll start with the fundamentals, helping you understand exactly how MITM attacks work and why they're so dangerous. From there, we'll explore ARP spoofing using both the classic ARP spoof tool and the modern Bettercap framework. You'll learn how attackers can bypass HTTPS security through SSL stripping, and we'll finish by showing you how DNS spoofing with Bettercap can redirect traffic to malicious destinations. But before we begin, let's address the elephant in the room. With great power comes great responsibility. Everything you'll learn in this video is intended for educational purposes and ethical penetration testing only. Using these techniques without authorization is illegal and could result in severe consequences. As ethical hackers, our goal is to understand these attacks so we can better protect against them. So, grab your notebook, fire up your testing environment, and let's dive into the world of MITM attacks. Imagine you're passing notes in a classroom. You trust that your note will go directly to your friend. But what if someone intercepts that note, reads it, maybe changes it, and then passes it on? That's essentially what a man-in-the-middle attack does in the digital world. First, let's set the stage. MITM attacks can only be performed once an attacker has connected to a network. Once connected, the attacker can redirect the flow of packets. Think of these as digital notes, from any client to their own device. This means every piece of information sent to or from the clients must pass through the attacker's device. Now, you might wonder, why is this attack so powerful? The answer lies in a protocol called ARP, or Address Resolution Protocol. ARP has two major security flaws that make MITM attacks possible. First one is blind trust. Each ARP request and response is automatically trusted. If a device on the network claims to be the router, other devices believe it without verification. It's like if someone in a mask walked into your classroom and said, "I'm the teacher now," and everyone just accepted it. Second, unsolicited responses. Devices can accept responses even if they didn't send a request. Imagine if you could just walk up to someone and say, "Here's the answer to the question you were about to ask," and they'd believe you, even if they weren't planning to ask anything. These flaws allow attackers to use a technique called ARP poisoning or spoofing. Here's how it works. Picture a typical Wi-Fi network. When a client wants to access a website, it sends a request to the Wi-Fi router, which then fetches the information from the internet and sends it back to the client. In an ARP poisoning attack, the attacker sends an unsolicited ARP response to the client. This response essentially says, "Hey, I'm the router." The client, trusting this information, starts sending all its packets to the attacker instead of the real router. But the attacker doesn't stop there. They also send a message to the real router saying, "Hey, I'm the client." Now the router starts sending its responses to the attacker instead of the real client. By doing this, the attacker places themselves right in the middle of the communication stream. Every packet, every digital note, now passes through the attacker's device. It's like if all the notes in the classroom had to go through one person before reaching their intended recipient. Let's walk through a practical example. A client wants to visit google.com. Instead of sending this request to the Wi-Fi router, it sends it to the attacker's device, thinking it's the router. The attacker can then forward this request to the real router. When the router sends back the web page data, it goes to the attacker's device, thinking it's the client. The attacker can then forward this data to the real client. This positioning gives the attacker immense power. Since all the traffic is flowing through their device, and they have the network key, they can read the packets. They can see all the information being sent and received. They can change the content of the messages. They can choose to not forward certain information at all. It's like having the ability to read every note in the classroom, change what they say, or even prevent some from being delivered altogether. What makes this attack particularly dangerous is how difficult it is to detect and prevent. The ARP protocol, which is fundamental to how networks operate, inherently trusts these kinds of messages. It's a bit like trying to play a game where one of the basic rules makes cheating easy. So, how can you protect yourself from MITM attacks? While it's challenging, there are a few steps you can take. First, use encrypted connections like HTTPS whenever possible. This makes it harder for attackers to read or modify your data, even if they intercept it. Second, be cautious when connecting to public Wi-Fi networks. These are prime targets for MITM attacks. Third, use a virtual private network, VPN. This encrypts your traffic before it even leaves your device. Fourth, keep your systems and software up to date. This ensures you have the latest security patches. Fifth, use network monitoring tools that can detect unusual RP activity. Remember, awareness is the first step in protection. By understanding how MITM attacks work, you're better equipped to recognize and avoid potential threats. Let's start by understanding what ARP spoofing is all about. ARP, or Address Resolution Protocol, is like the phone book of your local network. It's responsible for mapping IP addresses to physical MAC addresses. When a device wants to communicate with another on the same network, it uses ARP to figure out which physical device corresponds to a particular IP address. Now, imagine if someone could manipulate this phone book, redirecting all your calls to them instead of the intended recipient. That's essentially what ARP spoofing does, but with network traffic instead of phone calls. To demonstrate this attack, we're going to need two machines, a Windows PC as our target and a Kali Linux system as our attacker. Let's start with our Windows machine. First, we need to gather some information about our network. On the Windows PC, open up PowerShell. You can do this by right-clicking the Start menu and selecting Windows PowerShell. Once it's open, type in the following command, ARP-A. This command displays the ARP cache, which shows us the current IP to MAC address mappings known to this machine. Look for the first entry that has an IP address ending in .62. This is our router. Make a note of both its IP address and MAC address. And all of the above is the IP address of our Windows machine. Both of these will be used in the attack. In this example, 192.168.233.62 is the router's IP address, and next is its MAC address. Your specific addresses will be different, so make sure to use the ones you see on your screen. Now that we have our target information, let's switch over to our Kali Linux machine. This is where the magic happens. Open up a terminal and run this command, sudo su. Enter your password when prompted. You should now see a symbol at the start of your command line, indicating you have root access. Next, we need to install a package called dsniff, which contains the ARP spoof tool we'll be using. Run this command, apt install dsniff. If it asks for confirmation, type Y and press enter. Now dsniff is installed. We need to find out our IP address on the Kali machine. Open up a terminal and run these two commands, hostname I. This will show you the IP address of your Kali machine. Make a note of it. Next, run iproute grep default. This command will show you the default gateway, which is typically your router's IP address. It's good to double-check this against the information we got from the Windows machine. Now that we have all our network information, it's time to set up for the attack. In the Kali terminal. Now we're ready to launch our ARP spoofing attack. We're going to run two separate ARP spoof commands, each in its own terminal window. These commands will trick both the router and the target Windows machine into sending their traffic through our Kali machine. In your current terminal, run this command, ARP spoof, where I represents the network interface, which is WLAN 0, and T represents the target IP address. In our case, it is the IP address of our Windows machine, which is 192.168.233.105. Then next is the IP address of our router, which is 192.168.233.62. Replace 192.168.233.105 with the IP address of your Windows target, and 192.168.233 192.168.233.105.62 with your router's IP address. This command tells the router that we are the Windows machine. Now, open a new terminal window. You can do this by pressing Ctrl-Shift-T, gain root privileges again with sudo su, and run this second command, ARP spoof, where I represents the network interface, which is WLAN 0, and T represents the target IP address. In our case, it is the IP address of our router, which is 192.168.233.62. Then next is the IP address of our Windows machine, which is 192.168.233.105. This time, we're telling the Windows machine that we are the router. With these two commands running, we've effectively placed ourselves in the middle of the connection between the Windows machine and the router. Any traffic between them will now flow through our Kali machine. But we're not done yet. By default, Linux will drop packets that aren't meant for it. To make sure the network still functions and to avoid suspicion, we need to enable IP forwarding. In a new terminal window, run echo1 proc sysnet IPv4 IP_forward. This command tells Linux to forward any packets it receives that aren't meant for it, allowing normal network traffic to continue. To verify that our attack is working, go back to the Windows machine and run a RPA again in PowerShell. You should now see that the MAC address associated with the router's IP address has changed. It should now match the MAC address of your Kali Linux machine. Congratulations! You've successfully executed an ARP spoofing attack. What's the next move in your security assessment? The tool we'll be using today is called Wireshark. It's a powerful open-source packet analyzer used by network administrators and security professionals worldwide. Let's walk through the process step by step. First, open Wireshark on your Kali Linux machine. You can do this by typing Wireshark in the terminal or finding it in the Applications menu. When Wireshark opens, you'll see a list of network interfaces. Select the interface you used for the ARP spoofing attack. In our case, it's WLAN 0. Now click the blue shark fin icon at the top left to start capturing packets. You'll immediately see a stream of packets flowing through your machine. It's like watching the Matrix. But all this data can be overwhelming, so let's focus our analysis. To make things easier, we'll set up a filter to look at HTTP traffic, which is often unencrypted. In the filter bar at the top, type HTTP and press enter. With our filter in place, now we wait. In a real attack scenario, the attacker would patiently monitor the traffic, waiting for the target to visit websites or enter sensitive information. For our demonstration purposes, let's say our test machine visits an insecure website and attempts to log in. For this example, we'll use a purposely vulnerable website called Aquart, which is designed for testing web application security. On our target machine, we'll navigate to VulnWeb. This is a deliberately insecure website used for testing purposes. Remember, never enter real credentials on sites like this. As we watch our Wireshark capture, we'll see the HTTP requests start to appear. Now, let's simulate a user logging in. On the target machine, we'll enter the following credentials: username, TechSky, and password, subscribe. In Wireshark, we'd see a post request to the login page. Right-click on this packet and select Follow HTTP Stream. A new window will open, revealing the contents of the HTTP request. In plain text, you might see something like this. Just like that, we've captured a username and password. In a real-world scenario, this could be absolutely devastating. But this is precisely why we always stress the importance of using HTTPS. Now, let's get into the nitty-gritty of how we can perform this attack using Bettercap. We'll be using Kali Linux, a distribution designed for penetration testing and ethical hacking. If you're following along, make sure you're in a controlled environment where you have permission to perform these actions. To start, we need to make sure we have Bettercap installed on our system. Open up your terminal in Kali Linux. The terminal might look intimidating if you're new to it, but think of it as a direct line of communication between you and your computer. We're going to type in some commands, and the computer will execute them for us. First, let's update our system's package lists. Type in sudo apt-update and press enter. You might be asked for your password. This is normal. The sudo part of the command gives us administrative privileges, which we need for installing software. apt is the package manager in Debian-based systems like Kali, and update tells it to refresh its list of available packages. Once that's done, we can install Bettercap. Type sudo apt install Bettercap and press enter. The system will ask you if you want to continue. Type Y for yes. This command tells the system to download and install the Bettercap tool. Great. Now we have Bettercap installed. But before we run it, we need to know which network interface we're using. Think of a network interface as your computer's gateway to the network, like a door that data passes through. Type ifconfig in the terminal. This will show you a list of your network interfaces. Look for WLAN 0 if you're on Wi-Fi, or ETH 0 if you're using an Ethernet cable. For our demonstration, we'll assume we're using WLAN 0. Now we're ready to start Bettercap. Type sudo bettercap iface WLAN 0 and press enter. The iface WLAN 0 part tells Bettercap which network interface to use. You'll see Bettercap's command line interface pop up. It might look a bit bare bones, but it's incredibly powerful. Our first step in the attack is to identify other devices on the network. Bettercap has a module for this called net.probe. To activate it, simply type net.probe on and press enter. This is like casting a wide net into the network sea, seeing what devices we can find. To see what our net has caught, type net.show. This will display a table of all the devices connected to the network, including their IP addresses, MAC addresses, and names. For our demonstration, we'll target the last device in the list, which we'll assume is our test Windows machine. Now that we've identified our target, it's time to set up our attack. We'll use a technique called ARP spoofing. Address Resolution Protocol, or ARP, is how devices on a network figure out which physical device corresponds to which IP address. By spoofing ARP messages, we can trick devices into sending their traffic through us. First, we need to enable full duplex mode for our ARP spoofing. Type set arp.spoof.fullduplex true. This allows us to intercept traffic in both directions, from the target to the router and vice versa. Next, we set our target. Type set arp.spoof.targets followed by the IP address of your target machine. This tells Bettercap which device we want to focus on. Now, let's start the ARP spoofing. Type arp.spoof on. At this point, we've positioned ourselves between the target and the router. Any traffic between them will now pass through us. Finally, we'll turn on packet sniffing. Type net.sniff on. This tells Bettercap to start capturing and analyzing the network traffic passing through us. And just like that, we're in the middle of the connection, able to see the network traffic. It's a powerful position, and in the wrong hands, it could be incredibly dangerous. Let's see this in action. On our target Windows machine, we'll open a web browser and search for vulnweb. This is a deliberately vulnerable website used for testing web application security tools. Click on the first Acunetics web result. For demonstration purposes, we'll use the login form on this site. Remember, never enter real credentials on insecure sites like this. Let's enter a username TechSky and password subscribe, then click login. Now, back on our Kali machine, let's examine the captured data. You'll see a lot of information scrolling by in the Bettercap interface. If you look carefully, you'll spot our entered username and password in plain text. This is why it's crucial to always use HTTPS, especially when handling sensitive information. Now that we've seen how a MITM attack works, let's talk about how to protect ourselves from these types of attacks. There are several key strategies we can employ. Always use HTTPS. This encrypts your traffic, making it much harder for attackers to read even if they do intercept it. Look for the padlock icon in your browser's address bar. It's a simple but effective first line of defense. Be cautious on public Wi-Fi. Public networks are prime targets for MITM attacks. Avoid accessing sensitive information when on public Wi-Fi, or use a VPN. Speaking of which, using a virtual private network is another great strategy. A VPN encrypts all your internet traffic, providing an extra layer of security. Keeping your software updated is crucial. This includes your operating system, browser, and any security software you use. Updates often include important security patches that can protect against the latest threats. Using strong, unique passwords won't prevent MITM attacks directly, but it can limit the damage if your credentials are intercepted. Coupled with two-factor authentication, you can add an extra layer of security, even if your password is compromised. Be wary of certificate warnings. If your browser warns you about an invalid security certificate, don't ignore it. It could be a sign of a MITM attack. Also, consider using a secure DNS service, which can help protect against some types of MITM attacks. For network administrators, there are additional steps you can take. Implementing DHCP snooping can help prevent ARP spoofing attacks on your network. Using static ARP entries for critical systems makes it harder for attackers to spoof ARP messages. Employing network segmentation limits the potential scope of an attack. And using intrusion detection systems can alert you to suspicious network activity that might indicate a MITM attack. Remember, cybersecurity is an ongoing process. Attackers are constantly developing new techniques, so it's crucial to stay informed and regularly update your security practices. In conclusion, man-in-the-middle attacks are a powerful technique that can be devastatingly effective in the wrong hands. As ethical hackers and cybersecurity professionals, understanding these attacks helps us develop better defenses and educate users about potential risks. Always remember to use your knowledge responsibly. The goal of ethical hacking isn't to cause harm, but to make the digital world a safer place for everyone. Have you ever wondered if your supposedly secure HTTPS connection could be secretly downgraded to an insecure HTTP1, leaving your sensitive data exposed? We're going to demonstrate an SSL stripping attack, which is a type of man-in-the-middle attack that downgrades a secure HTTPS connection to an unsecure HTTP1. This allows an attacker to potentially intercept and manipulate data that the user thinks is being sent securely. Let's start by setting up our attack environment. We'll be using Kali Linux, a distribution designed for penetration testing and ethical hacking. First, we need to gain root privileges. Open your terminal and type sudo su. This elevates our permissions, allowing us to install and run the tools we need. Next, let's make sure our system is up to date. Run apt update to refresh our package lists. This ensures we're working with the latest versions of our tools. For this demonstration, we need two key tools, SSLstrip and dsniff. SSLstrip is what we'll use to perform the actual SSL stripping attack, while dsniff contains tools for network auditing and penetration testing, including ARPspoof, which we'll use for our initial man-in-the-middle attack. Let's install SSLstrip first. Type apt install SSLstrip and press enter. Now let's install dsniff with apt install dsniff. If prompted, type E to confirm the installation. With our tools installed, we're ready to begin the attack. But first, we need some crucial information: the IP address of our router, the IP address of our target machine, and the network interface we're operating on. To find our router's IP address, we'll use the command route n. This displays the routing table, and the IP address listed under gateway is typically your router's IP. Now for our target machine's IP, we'll use nmap, a powerful network scanning tool. Run the command nmap ss o router IP24, replacing router IP with the address you just found. This scans your local network and lists all connected devices. Look for the entry that shows a Windows operating system. That's our target for this demonstration. Lastly, we need to know our network interface. Run ifconfig to see all network interfaces. Look for WLAN 0 if you're on Wi-Fi, or ETH 0 for a wired connection. Note the interface name and your Kali machine's IP address while you're here. Now that we have all this information, let's start our MITM attack using ARPspoof. Open a new terminal window, gain root privileges again, and run this command. ARPspoof I network interface, T target IP, router IP. This command tells the target machine that our Kali machine is the router. We're not done yet. Copy this command, open a new terminal, and paste. But swap the target IP and router IP. This fools the router into thinking our Kali machine is the target. Run both these commands simultaneously in separate terminal windows. With these commands running, we've successfully positioned ourselves between the target and the router. But we're not done yet. We need to ensure that traffic can still flow through our machine. Run this command. Echo 1 proc sysnet IPv4 IP_forward. This allows our Kali machine to pass network traffic from the router to the target machine without interruption. Next, we need to configure our IP tables to redirect traffic. Run this command. IP tables tnat a pre-routing PTCP D port 80 J redirect to port 8080. This redirects all traffic destined for port 80 HTTP to port 8080, where our SSL strip will be listening. Finally, we're ready to run ssstrip. Clear your terminal and type sslstrip L8080. And there we have it. We've successfully set up an SSL stripping attack. In theory, this would allow us to intercept and potentially manipulate data that the user thinks is being sent securely over HTTPS. However, it's crucial to note that this attack isn't as effective in 2024 as it was when first introduced. Many websites now use HTTP Strict Transport Security, HSTS, which forces browsers to use HTTPS connections. Modern browsers also have built-in protections against these types of attacks. To successfully downgrade a website, you'd need to use an outdated browser that doesn't support HSTS, like older versions of Internet Explorer. The cybersecurity landscape is constantly evolving, with new protections being developed all the time. Now, let's talk about how to protect yourself and your users from SSL stripping attacks. Here are some key strategies. First and foremost, always use HTTPS. As a website owner, implement HTTPS across your entire site, not just on login pages. Use HSTS headers to force browsers to always use HTTPS connections to your site. For users, be cautious when browsing, especially on public Wi-Fi networks. Look for the padlock icon in your browser's address bar, which indicates a secure HTTPS connection. If you see a warning about an insecure connection, don't ignore it, it could be a sign of an SSL stripping attack. Keep your software up to date. This includes your operating system, web browsers, and any security software you use. Updates often include important security patches that can protect against the latest threats. Consider using a virtual private network, VPN, especially when on public Wi-Fi. A VPN encrypts all your internet traffic, providing an extra layer of security. For network administrators, implement security measures like HTTPS inspection and SSL TLS monitoring. These can help detect and prevent SSL stripping attacks on your network. Educate your users about the importance of secure connections. Teach them to be wary of entering sensitive information on websites without HTTPS, and to pay attention to security warnings from their browsers. Finally, consider using browser extensions that force HTTPS connections whenever possible. While not foolproof, these can provide an extra layer of protection against downgrade attacks. Remember, cybersecurity is an ongoing process. Attackers are constantly developing new techniques, so it's crucial to stay informed and regularly update your security practices. Understanding DNS spoofing. Let's start with the basics. When you type a website address into your browser, your computer asks a DNS server, "Hey, what's the IP address for this website?" It's like looking up a phone number in a phone book. DNS spoofing is when an attacker intercepts this process and says, "Oh, I know that address," but gives you a fake one instead. Your computer, trusting as it is, follows the fake direction and ends up at the attacker's website instead of the real one. Required tools and setup. For today's demonstration, we'll need several tools installed on our Kali Linux system. We'll be using Bettercap for the actual DNS spoofing, Apache 2 as our web server to host the fake page, and Nmap for network scanning. If you're following along, make sure you have these installed on your Kali Linux machine. Initial information gathering. Let's begin our practical demonstration. First, open your terminal on Kali Linux. Everything we're going to do requires root privileges, so let's start there. Type sudo su and enter your password. This gives us the necessary permissions for all our upcoming commands. Now we need to gather some critical information about our network. First, we need to know our network interface name. Type ifconfig in the terminal. Look at the output carefully. You'll see various network interfaces listed. We're looking for our wireless interface, which is usually called WLAN 0. You'll see its IP address listed right there as well. Make a mental note of this IP address, we'll need it later. Next, we need to find our router's IP address. Type root N in the terminal. In the output, look under the gateway column. This IP address is our router's address. Write this down or keep this terminal open. We'll need this information throughout our attack. Now comes the interesting part, finding our target machine. We'll use a tool called Nmap for this purpose. Nmap is like a sophisticated radar for computer networks. Type Nmap SSO followed by your router's IP address and 24. This tells Nmap to scan your entire local network. The scan might take a few minutes, but it will show us every device connected to our network. Look for the IP address of your target machine in this list. Website preparation. Now that we have our network information, we need to prepare the fake website that our target will see. First, let's install a graphical text editor to make our life easier. Type sudo apt install gedit and press enter. Type Y when asked for confirmation. We're going to use Apache 2 web server to host our fake page. Apache 2 comes with a default web page that we need to modify. Type sudo gedit /var/www/html/index.html. This opens the default web page in our text editor. Clear out whatever is there. We're going to replace it with our own code. For demonstration purposes, we'll create a simple web page about a RP spoofing. You can use any HTML code you want here, but make sure it's convincing if you're trying to create a realistic scenario. After pasting your HTML code, save the file and close gedit. Next, we need to set the proper permissions for our web page. Type sudo chown www.data/var/www/html/index.html. This ensures Apache 2 can serve our page correctly. Now let's start our web server. Type sudo service apache 2 start. Our fake website is now up and running on our local machine. Bettercap configuration. Here's where things get interesting. Bettercap is our main tool for DNS spoofing, but it needs some configuration first. Type sudo gedit /etc/ettercap/eder.conf to open the Bettercap configuration file. In this file, we need to make two important changes. First, find the lines containing ec_uid and ec_gid. These values need to be changed to 0. This gives Bettercap the necessary permissions to modify network traffic. Scroll down further until you find the reader_command_on and reader_command_off lines, both for IPv4 and IPv6. They'll probably have a symbol in front of them. Remove these symbols to uncomment the lines. These commands allow Bettercap to redirect network traffic. Save and close this file. Now we need to configure the DNS spoofing rules. Type sudo gedit /etc/ettercap/eder.dns. This file tells Bettercap which domains to spoof and where to redirect them. Add the following lines, replacing with your actual Kali machine's IP address. These lines tell Bettercap to redirect any requests for vulnweb.com to our machine instead. Save and close this file. Launching the attack. Now comes the moment of truth. Open a new terminal window and type sudo ettercap tq iwlan0 marp remote target IP router IP DNS_spoof. Replace target IP with your target's IP address and router IP with your router's IP address. This command starts Bettercap in text mode, stays quiet about non-important stuff, uses our wireless interface, performs ARP poisoning, and enables DNS spoofing. If everything is set up correctly, you should see Bettercap spring into action. When your target tries to visit vulnweb.com, they'll be redirected to your fake page instead. Monitoring the attack. Once the attack is running, Bettercap will show you information about the DNS requests it's intercepting. You'll see when the target tries to access vulnweb.com, and Bettercap will show you that it's redirecting them to your fake page. Protection against DNS spoofing. Now that we understand how devastating DNS spoofing can be, let's talk about how to protect ourselves against these attacks. I'm going to share several crucial protection measures that will significantly reduce your risk of becoming a victim. First and foremost, implement domain name system security extensions, also known as DNSSEC. This technology adds digital signatures to DNS records, making it extremely difficult for attackers to serve fake responses. When your computer queries a DNS server, these signatures are checked to verify the authenticity of the response. Think of it like a digital seal of authenticity for website addresses. Using encrypted DNS protocols is another powerful defense. DNS over HTTPS or DNS over TLS encrypts your DNS queries, preventing attackers from seeing or modifying them. Many modern browsers support these protocols out of the box. You can also use secure DNS services like Cloudflare's 1.1.1.1 or Google's 8.8.8.8, which provide additional security measures against spoofing attacks. Virtual private networks add another layer of protection, especially when using public networks. A VPN creates an encrypted tunnel for all your internet traffic, making it much harder for attackers to intercept and manipulate your DNS requests. Always use a VPN when connecting to public Wi-Fi networks. Network administrators should take additional steps to secure their infrastructure. This includes regular updates to DNS servers, implementing proper access controls, and restricting zone transfers. Setting up proper monitoring systems can help detect suspicious DNS activity before it becomes a problem. For corporate environments, network segmentation is crucial. By properly segmenting your network and implementing strict access controls, you can limit the scope of potential DNS spoofing attacks. Use firewalls to restrict DNS traffic to trusted servers only, and regularly audit your DNS configurations for unauthorized changes. Regular monitoring of DNS traffic patterns is essential. Look for unusual activities like excessive DNS queries or responses from unknown DNS servers. Tools like Wireshark can help identify suspicious DNS traffic on your network. System updates play a vital role in protection. Keep your operating system, browsers, and network-related software up to date. Many updates include security patches that protect against known DNS vulnerabilities. Enable automatic updates whenever possible to ensure you're always protected against the latest threats. DNS filtering solutions can provide an additional security layer by blocking access to known malicious domains. These tools can help prevent users from accidentally accessing compromised websites and can stop DNS spoofing attacks before they begin. For critical systems, maintaining a local host file with verified IP addresses adds another layer of security. While this isn't practical for all websites, it can provide additional protection for accessing crucial services that shouldn't change IP addresses frequently. User education is perhaps the most important protection measure. Understanding the risks of DNS spoofing and knowing how to recognize potential attacks is crucial. Watch for certificate warnings, unexpected redirects, and websites that don't use HTTPS. If something seems off about a website, trust your instincts and verify the site through other means. Conclusion: DNS spoofing is a powerful technique that demonstrates just how vulnerable our online activities can be. We've seen how attackers can redirect traffic to fake websites, potentially capturing sensitive information like passwords and credit card numbers. But we've also learned about numerous ways to protect ourselves and our networks from these attacks. Thank you for watching this comprehensive guide on DNS spoofing. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more cybersecurity content. Drop your questions in the comments below, and let me know what topics you'd like to see covered in future videos. Stay safe, stay ethical, and keep learning.